Thus far, we've really talked only about how to program with some of these features, in particular supply sync and factor methods. Now we're going to take a look under the hood and see how these features are implemented. And this is actually, I think this is really cool because it gives you a sense of the level of insight and creativity that went into building this framework in the first place. So we're going to focus on how supply async maps to the common fork join pool. And we're also going to see how supply async runs a supplier lambda concurrently and asynchronously. By the way, I asked ChatGPT to generate an example of the internals of factory methods with the Java CompletableFuture framework. And it came out with a pretty cool diagram, but one of the funny things about trying to use ChatGPT, it's actually DALL-E 3, is it just has the hardest time trying to come up with the correct labels for things. I haven't the faintest idea why it is so challenged in this regard, but if you look at this stuff, you can see it's trying to do something with completion stages and execute completable futures and completions and all kinds of stuff, but it's like it's written in a foreign language or in a space language, like something from another dimension. And I think that's really funny. But I do like the diagram. That's kind of cool. So let's talk about how this works. So again, we're going to revert back to the running example we've seen a couple times now where we've got a couple of strings with big fractions, and we're going to call supply sync, and we're going to give it a supplier lambda, which comes out of this EX8 project in my Java 8 folder in the live lessons GitHub repository. So this is going to run things in the common fork join pool. So notice, first and foremost, we don't have to make a new thread. That's done by the underlying common fork join pool. So even supply async really isn't creating a new thread. It's doing all this magic under the hood. Instead, supply async is going to return a completable future that will be completed ultimately by a worker thread that's running in the common fork join pool. Now, we may or may not have time in this class to show how you can do other things to the way that the fork join pool works internally. I may or may not have time for that. It's really cool, but we'll see how it turns out. It turns out using some super advanced features of the Completable Futures framework that came around a little bit later than Java 8, you can actually take control of the way in which this stuff works, where the threading works, where you can actually use Java virtual threads to create virtual threads to run each completable future, which is a really interesting concept. And I've got an example, and if we have time, we'll look at that. At any rate, what happens here is supply async is going to take this supplier lambda that multiplies two big fraction objects together, and it's going to stash it away. And again, we're using the effectively final variables to pass parameters to that supplier lambda. And what happens here is that this supplier lambda, as we will see momentarily, is actually passed down through a couple of internal calls, and it ends up getting queued in the completable future framework in the calling worker threads work queue or double-ended queue deck. And then it's going to ultimately have one of the worker threads in the pool, either the one where it was called from or someone who stole it, will call the get method on this supplier lambda in a totally different thread context to obtain the supplier lambda and perform the computation that it embodies. So that's what's going to happen here. We'll take a look at that. So let's see how this works under the hood. So here is the supply async method. You can go take a look in the source code of Java to see how this works. You can use any version after Java 8. The newer versions are a little bit cooler, but the basic workflow is about the same as what I'm going to show you here. So here's supply async. You can see supply async takes a lambda, takes a supplier, parameter is by type u. This is a static method, so type u is provided as a parameter for that static method. And as you can see, supply async is going to pass the supplier into a helper method called exec async after first encapsulating it with something called async supply. So let's take a look at some of these things. So first, this is what the supplier maps to for our particular example. This is the one where we're going to pass in that supplier lambda that multiplies two big fractions together. So it's bound. It's the fancy way of saying the lambda expression is bound to this parameter. Internally, supply async creates a new completable future that's incomplete. So I should have the donut here without the donut hole, showing that it's an incomplete placeholder. So we make an incomplete completable future. And then we take that incomplete completable future, we take the supplier that was passed in as a parameter, we wrap that up inside a helper class called async supply, and then we give that to the async exec async method, passing also in the common fork join pool. So the common fork join pool is used to execute this async supplier in some background thread. I talked earlier about how the reactive programming manifesto talks about the message-driven principle. Well, this is an example of the message-driven principle in action because we're passing this code as a message. So this is a method call, supply sync, that takes its parameter plus an incomplete future, wraps it up, makes a new instance of async supply, which now becomes a message, and that gets passed down into the framework. So this is the message-driven part of reactive programming. You'll also notice that what gets returned from this, from supply sync, is this incomplete future. So we're giving back an incomplete future, which will then be completed at some point after this async supply object is run in the context of the common fork join pool. All right, let's take a look at async supply. Async supply, it's also part of the completable future interface, of the class rather. Remember I talked before about how completable future is a wrapper, and it provides a fairly hefty set of public methods. There are about 60 of them, but then it's also got a whole boatload of fields, private methods, and nested classes. Well, async supply is one of those nested classes. And you can see that async supply extends async. And if we peek down the inheritance chain a bit, we'd see that async extends fork join task and runnable, so it can be executed by a worker thread in the common fork join pool. Great. There are then a couple of fields here. We have the supplier and this completable future, and you can see that those are what are passed in. This supplier field is going to contain the supplier lambda that was passed to supply async by the application code way back, and this dest thing is the incomplete completable future. So those things are stashed away in these fields. And then, at some point, a worker thread in the common fork join pool is going to call the exec method. And this is what I believe gets inherited from fork join task. And what that does is that goes ahead in a background thread, in the worker thread. It's going to call the get method on the supplier function. I'm not sure why they didn't call it sup instead of fun for function, but it's going to call the get method here. That's running in the background. That'll return a value. And this call to get, remember this is not the future get, this is the supplier get, will use the fork join pool manage blocker mechanism to auto-scale the common pool size for blocking operations, if you so do it that way. You can decide how it works. This particular example doesn't do that, but you can do that your assignment 4. In fact, we'll be doing that. So this thing runs in the background, may or may not create a compensating thread in the common fork join pool. The result comes back, and then the implementation of exec calls the internal complete method on the destination, which is this guy, passing in the result and an exception, which we didn't have in this case. And that will then trigger or complete the completable future using the parameter that comes back here. So that's how the application, which called supply sync and gets back a completable future, will ultimately have that completable future completed or triggered after this call is done internally. And I'm obviously skipping through lots of other implementation details that are super cool, but they distract from the overall story we're trying to tell. So this is how things get executed in a background thread. So that's the end of the completable futures, factory methods, internals discussion. I find that quite interesting. What's also quite interesting from my point of view is how this ties together lots of other things we've been talking about in the class, such as how the common fork join pool works, and work stealing, and the double-ended queue. We also see here how various functional Java features like lambda expressions and functional interfaces get used in the context of this implementation as well.